guys, so today we're going to be going over Taylor and Maclaurin series. So, your calc teacher might have just thrown this formula at you, and it looks insane, but by the end of this video, it's going to make complete sense. Alright, so let's just break down the formula first, and then we can jump into some problems. So, the formula says f of x, which is the function they give you. The first step you do when you're finding a Taylor-Maclaurin series is you take f of a, so all you have to do is plug a into your function. Now what is a? A is where the series is centered. And you might be confused on what that means, but you know it's going to make sense. In Maclaurin series, the center is always 0. No matter what, it's always going to be 0. In Taylor series, they're going to give you the center. They might say, oh, find the Taylor series when it's centered at 5, or find it when it's centered at like pi over 2, whatever it may be. So that's all it is. They're going to give you the center, and all you have to do is just plug it in. Now, once you plug in the center into your original function, then you take the derivative of your function and plug in the center, and then it's x minus a over 1 factorial. Alright, then plus the second derivative of the function times x minus a squared over 2 factorial. Plus f to the nth derivative of a times x minus a to the n over n factorial. So you guys kind of see a pattern, right? All you're doing is you're taking one more derivative and then putting it to the exponent 1 higher, and then divided by factorial 1 higher, right? So it's just f to the nth derivative of a times x minus a to the n over n factorial. That's it. This might seem a little bit confusing, but we'll be going into our first example. So, first step, what I like to do is I just write what they gave me, f of x equals e to the x. Now, remember, we have to find some derivatives. So, they're saying write the Taylor series, so that means you're probably going to have to do it in like summation notation. But let's see some terms so we can kind of gauge what our summation notation needs to look like. So, f prime of x, well, the derivative of e of x is just e to the x, sorry. And then same thing, f double prime of x, it's just e to the x. Now, look at our formula. F of a, so all we have to do, we take the first derivative, right? Or not even the first derivative, you take the function, you plug in 1. So it'll be e, and then plus, the same thing, we plug in 1 to our second derivative, e, and now this is when the x minus a, it's centered at 1, so a is 1, over 1 factorial, right? We're following our formula. Alright, now let's take the second derivative, e to the x again, so it'll be e again, to the x minus 1 squared over 2 factorial. And you might be thinking, oh, why doesn't this first term have anything? Well, let's think about that. We can just write it, this is e, right? And it'll be x minus 1, except if this is 1, there'll be 0, and this is over 0 factorial. Well, x minus 1 to the 0 is 1, and 0 factorial is 1, so that just becomes e, right? So, if you were wondering about that, it's just kind of simplified already. So now, we know like kind of what our function is looking like. So I think we're ready to write our summation notation. So infinity n equals 0. Alright, well, every single term I see an e, so we're going to write e. And then I always see an x minus 1 for every single term. Alright, so x minus 1. And then I see there's always like a power, right? This is to the 1 and this is to the 2. So it's the nth power over. And the last thing I see is we have a factorial, right? So it's n factorial. And that's all it is, right? Even for this one, like I just showed you guys, it's just e to the e times x minus 1 to the 0 over 0 factorial, right? So if you plug in 0 here, you're going to get e. So this is all it is. So this is the Taylor series for f of x equals e to the x centered at 0. Okay, let's move on to our next question. Oh, find the Maclaurin series for, find the Maclaurin series for sine of x. Okay, well, same thing. What I like to do is just write down my first function that they gave us. Then we're just going to take a couple derivatives. So f prime of x is just cosine x, right? The derivative of sine is cosine. F double prime of x is what? Negative sine of x. And now we're ready to keep going, right? So remember, like I said, Maclaurin series are always centered at 0. So I'm just going to write it here so we don't forget. Center at 0. So we can like start doing our work. First step, we take our function sine and then plug in 0, our center as x. Well, I'll just keep it as sine of 0, and then plus take our first derivative. So, cosine. You plug in 0, and then it'll just be x minus 0 over 1 factorial. And same thing, actually this will be a minus, right? Because look, this is a minus sign. So minus sine of 0, x minus 0 over 2 factorial, and this is squared. Alright? So now we can start simplifying it a little bit more, just to make it a little bit easier for us to see. So, sine of 0. What is sine of 0? Well, at this you should have your trig values memorized. Well, sine of 0 is just 0. Cosine of 0 is 1, so this just becomes x over, I'll just write x, it'll be x over 1, so just x. Minus sine of 0 again is just a 0, so this becomes 0. Okay, so now, this is weird, I'm only left with an x. Okay, so in things like this, you're gonna wanna have to go a little bit further than just 2 derivatives, okay? So, let's keep going. F triple prime of x, well, what is the derivative of negative sine x? Negative cosine x. And then the fourth derivative of x is sine x. And I think 5 derivatives should be good. You don't you don't need to write all these hash marks out, but there we go. So now let's keep going with our formula. Let me make this a little bit smaller so we have more space. Okay, so plus our next term is gonna be here. Right here. We're gonna use these 3 right here. Okay, so remember, this is also gonna be a negative. So this is gonna be negative cosine of 0 x minus 0 cubed over 3 factorial, right? Because we're at the third derivative, so it's over 3 factorial over 3 cubed. Alright, so now we can keep going. Plus, it's again, same thing, sine of 0. Okay, we kind of know this is going to be, this term right here that I'm writing out is going to cancel because sine of 0 is just 0. And I'm not going to write x minus 0 anymore. You guys know that's x, so x to the 4th over 4 factorial. Let me make this smaller again. My handwriting's too big. Alright. And then plus cosine. So, do you guys notice that it only works when we have a cosine? Right? Because if we have a sine, then sine of 0 is just 0. And if the numerator is 0, then everything else is 0. So, I'm just going to cross out the ones that have sign. So we don't need this one. We don't need this one because these are all going to be 0 anyway. We don't need this one. Alright, so we're left with 3 terms, and I think that's enough to find a pattern. So cosine of 0 is just 1, so it would be x over 1 factorial, which is just 1, minus cosine of 0 is just 1, so it's just x cubed over 3 factorial, plus cosine of 0 is 1, so it'll just be x to the 5th over 5 factorial. Let me just write 1 factorial here. All right, so do you guys kind of see a pattern? It's the odd numbers, right? It's the odd. So 1, 3, 5, and then same thing in the numerator. 1, 3, 5. Each term, the exponent and the factorial, is increasing in terms of odd numbers. Okay, so I think we're ready to write down our summation notation. So, what do you guys think it will be? Well, another thing that we should point out is it's alternating, right? This is a positive, this is a negative, and this is a positive. So this means it's an alternating series. So that's the first thing I'm going to want to write. So -1 to the n. Okay, that's the first thing I'm going to want to write. Now, how do I get an odd number? Well, there are two ways you can get an odd number. So 2n is obviously going to be an even number. You either subtract 1 from it or you add 1 from it. In this case, since we're starting at n equals 0, we're going to want to add 1 to it. Because if we subtracted 1, I'll just show you guys really quick. If we subtracted 1, we're starting at 0. It would be 0 minus 1 equals -1. The first term is not x to the -1. It's x to the 1. So if we use x 2n plus 1, we get 0 plus 1, which is correct. So that so that means it's going to be x to the 2n plus 1. And the same thing here is the factorial matches the exponent. The factorial matches the exponent. So our numerator is going to be the exact same. And here's like a kind of like a little trick. I'd say about like 90% of the time, the exponent and the bottom are going to be the same. Not every time, but most of the time. Alright? So this is my answer. So it's not so bad once you get the hang of it. Now, I will say, there are a lot of Maclaurin series that you guys are going to need to memorize. So you're going to need to memorize this eventually. Sine x, you're going to need to memorize cosine x. You're going to need to memorize e to the x, ln x, whatever. You're going to need to start memorizing these. Alright, so let's move on to our next one. Find the Taylor series for ln x centered at 1. Alright, so let's, I don't know, what color do you guys want to use? Blue? Alright, yeah, we'll use blue. Alright, so remember, guys, first step, we're going to want to write out our function. So ln x, and then we start taking derivatives. F prime of x equals, that's just 1 over x. And then f double prime of x is just going to be negative x to the -2. F triple prime of x is going to be 2x to the -3. Alright, so this isn't bad. I think will be good enough. If not, we can always like write more. So let's start with our Taylor series. It's centered at 1 this time though. So let me write that out actually. Centered at 1. So first step, we just write our function and plug in the center. So ln of 1. Let me write it a little bit smaller. Ln of 1 plus our first derivative, we plug in 1. That's just 1 to the x minus 1, right? X minus our center over 1 factorial, and keep going. Oh, this is going to be a negative, so it's going to be negative, right? -1 over x minus 1 squared over 2 factorial plus, oh, this one's a little bit different. This one's 2x minus 1 cubed over 3 factorial. Okay, and then plus ... So I think we're good enough, right? We can start simplifying. Well, ln of 1 is just 0, right? So I'm just not going to write that. So now we have x minus 1 over 1 factorial, which is just 1, minus x minus 1 squared over 2 factorial, which is just 2, plus 2 over x minus 1 cubed over 3 factorial. Now I'm going to write this out. 3 times 2 times 1. These cancel. So actually, we can write this as, since the 2's, well, I'll show you guys. Give me one sec. X minus 1 cubed over 3. Right? So if I just write it out right here. So x minus 1 cubed over 3 factorial, that's just 2 times x minus 1 cubed 3 times 2 times 1. Look, the 2's cancel. And this is going to happen for every term in the series, and you guys can try to expand that if you guys don't believe me. So, let's look at the pattern. Again, first thing is, this is a plus, this is a minus, this is a plus. We have an alternating series, so let's just get that out of the way. Okay, so we can write 0 as we usually do. And then let's figure out the pattern. Well, do you guys see? Let me just write this in blue. So 1, right? The exponents are increasing by 1, and the denominator is increasing by 1. And remember what I said before, right? 90% of the time, these two are going to match. So let's write that down. So, first, we have to write our alternating series, so negative 1 to the n over x minus 1 to the n over, n, right? If the exponents match, then the exponents here and the denominator here should match. So do you guys see a problem? Well, if we actually were to plug in 0, we'd get undefined, because you can't divide anything by 0. So, oops, that's not what I wanted to do. We're going to have to start from not n equals 0, but n equals 1. Now, the first thing that I like to do, just to check myself, is to actually plug in n and see if my first term matches up. So my first term is x minus 1. So let's just plug in our first term 1. So it's just going to be negative 1 times x minus 1. So this is negative x minus 1. And that is not what we got. We got a positive x minus 1, which means that our first term, negative 1 to the n, has to be positive. And how do we do that? Add 1. So it becomes squared. So now if we plug it in, it will be negative 1 squared times x minus 1 to the 1. Right? This little thing changed our whole thing, changed our whole series. Now our negative 1 squared is 1, and that's positive, and that's what we want. So it's important that you guys kind of check these things, because it's really easy to make a lot of mistakes everywhere, because you're kind of so used to like writing, oh, from n equals 0 to infinity, but you have to check, like, oh, if I put in 0, that's going to be undefined. Alright, so that's our second question, or third question, done. Oh, we already did. Alright, so last question. Find the Maclaurin series for ln of 1 plus x. So this is going to be the hardest one we've done. So first thing, it always boils down to these steps. Just write down what you know. We know 1 plus x, and it's a Maclaurin series, so that we know center at 0. Alright, so I know you guys might be wondering, what's the point of Maclaurin series? Like, what's the difference? It's just that Maclaurin series are always centered at 0. So a Maclaurin series is like a type of Taylor series. Alright, so now let's start finding our derivatives. F prime of x. You guys are going to need to use a little bit of chain rule. 1 plus x. Now f double prime of x is going to be negative 1 over 1 plus x squared. F triple prime of x, so the third derivative, is going to be 2 over 1 plus x all cubed. Right? And I really suggest you guys go through and actually do these derivatives. I just do know this because I've done this so many times, but I think it's good to get that practice in and just drill it into your head, so that you have nothing to worry about on the actual test. So let's evaluate. So center at 0. So we already wrote that down. So first thing, we're going to start writing down our f of x. So f of x is ln 1 plus 0. We're just going to plug it in. Plus, this is just going to be 1 over 1 plus 0 times x minus 0, which is just x over 1 factorial, plus, what is this? Oh, this is negative. Okay, another alternating series. It's going to be negative 1 over 1 plus 0 squared, x minus 0 squared over 2 factorial, plus Same thing, 2 over 1 plus 0 cubed. And I know this gets tedious, but you gotta do what you gotta do. And there are things you're gonna, like, eventually you're gonna memorize this. So ln of 1 plus 0 is just ln of 1, and ln of 1 is just 0. So let's write down, we just cancel this out. This one doesn't matter. This one's just 0. So now 1 over 1 plus 0 is 1, so this becomes x minus 0 is x over 1 factorial, which is 1, minus 1 over 1 plus 0 squared is 1 over 1 squared, which is 1, so minus 1 times x squared over 2 factorial, which is 2. Plus, again, 2 over 1 plus 0 cubed, that's 1 cubed, so 2 over 1 cubed is 2, plus 2. X minus 0 is just x cubed over 3 factorial. But do you guys, like, notice something? Do you remember in this problem, or which problem was it? Yeah, this problem, where we had this exact kind of same thing, right? So we expanded the factorial. So let's do that. So let's expand it. It was 2 times x cubed over 3 times 2 times 1. The 2's cancel, and I'm left with x cubed over 3. So that's how I'm going to rewrite it, just to make it a little bit easier for myself to see the pattern. So x cubed over 3. Alright, so I'm sure you guys are noticing a pattern. It's very similar to the one we did before. I would just write x over 1 to the 1, just so you guys can really solidify it. Alright, so the factorials are increasing by 1, and the exponents are increasing by 1, and again, these two are the same. And it's not going to happen every single time, but majority of the time, if you're ever in a pinch and need to guess, just make it equal the same. So let's write our summation notation formula. Infinity n equals 0. We'll have to check that once we're done. So it's negative 1 to the n, right? Because it's alternating series. And now it'll just be x, right? There's an x in every term. And it's x to the first term, right? So if we start at 0, this will be n plus 1. And this will be n plus 1. Obviously, it will be n plus 1, because if I put in 0, it will be 1, x to the 1 over 1 is the first term. But also, look, they're the exact same. So, again, let's test out our first term. So, negative 1 to the 0 is just 1. X to the 0 plus 1 over 0 plus 1 is just x to the 1 over 1. That's exactly what we have for our first term. So, this is it. It's not difficult. It just takes a lot of practice, and it's going to take a lot of memorization. But the point I kind of really want to drill home is the more terms you have in your series, the closer it's going to be to your original function, right? I'll pop that video up again. You guys are seeing, like, as he's adding more terms, it's getting closer and closer and closer, right? So kind of like at the linear approximation, it was pretty good, but the square approximation is going to be better. The cubic approximation is going to be even better. So that's basically what a Maclaurin series does. I hope this all made sense. It's a lot to wrap your head around. But if I were you guys, this formula right here, like, you need to memorize this. This is your bread and butter. And then you're gonna need to memorize the common Maclaurin series. You can just find that, just search up common Maclaurin series formulas. There, I think you're probably maybe 5 you'll have to memorize. But you know, it's up to you. You can always rederive them, but I mean, I don't suggest that. That takes too much time, and you don't have that much time on the AP exam. But I will say, there's always one FRQ on the AP exam that's like a series. That's a Taylor Maclaurin series, whatever. It's just a series, and you're gonna wanna, like, crush that, because it's not difficult. The part where a lot of students get their points off is just because they're making, like, a silly mistake, like, oh, they didn't realize it was an alternating series, or oh, I accidentally wrote the center was 0 because I assumed it was a Maclaurin, even though they told us it was a Taylor, right? So all these things added up. Just got to be careful. But I hope this all made sense. Thank you guys so much for watching. If you have any questions, feel free to leave them in the comments below. If you have any videos that you guys want me to make or any ideas on how I can improve, let me know, and I'll see you guys in the next one.